Welcome to Ask and Learn.
Okay, so this problem says you have a wire and the wire is surrounded by a non-conducting coax. And then you're given the linear charge density. I'm going to call this lambda I for inner. And that's 3.6 times 10 to the minus 9 coulombs per meter. And the goal is to get the charge density on the outer surface. So I'll use sigma for density, for surface density, and O for outer. So yeah, basically the idea is I think that you have some charges here. I think they were positive. I'm just going to double check the problem in another window. Yeah, so charge outside surface. And then you want the net electron field to be 0. So yeah, so you have this positive charge here, and you're going to put some negative charges here, and you want the total electric field, I think, on the outside to be 0. And so the idea is you just want to have the same amount of charge on the inside as you do on the outside. So I'm going to write this at, so this is how I approached it. I'm sure there's different ways. So don't think this is the only way to formally write it, but it first struck me to say, okay, well, I need the charge per unit length to be the same on the outside as it is on the inside. So you can say lambda inner equals lambda outer. And so now we need to kind of put lambda outer in terms of sigma outer, because that's really what we're after. So what is sigma outer? So sigma outer is going to be the total amount of, so given some kind of cylindrical surface, it's the total amount of charge on that surface divided by the area of that surface. And then the area of a cylindrical shell is 2 pi r times the length of that shell. So I'll go ahead and draw that. Here's some radius. Here's some length. Of course, this extends infinitely, but this is just a portion of the wire. Great. And so now we have this in terms of the linear density, because keep in mind that the linear density is just charge per unit length. And so here we have charge, here we have length. So we can say that that's just going to be our lambda outer. And then that's just divided by 2 pi times r. And so, great, now we basically have all that we need, this formula. And so if you algebraically combine these two, then you'll get that. I'm just going to do this over here. So I'm kind of working in like a clockwise situation here. You'll get that lambda outer, maybe you'll get it. Maybe I made a mistake, but I don't think so. Or maybe you made a mistake. We all make mistakes. So anyway, combining this equation and this equation, I get that sigma outer is lambda inner divided by 2 pi r. And then if I plug in r is 0.015 meters, just do everything in SI, but you probably know that by now. And then lambda inner is like this, and then maybe you'll get 3.8 times 10 to the minus 8. And then I will circle that, because who likes a visual mess? Not me. Okay, wonderful.